Hello, today we're doing 4.3 notes. We're going to learn side, 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 and side, angle, side. So go ahead and take a second and do the first exploration. So go ahead, type in the link, click on the link if you have it available online, and then make a conjecture about it. Alright, now that you had a second to do that, let's go ahead and talk about side, side, side postulate, so SSS. If three sides of one triangle are congruent to three sides of another triangle, then the triangles are congruent by side, side, side. So if you want to write the word, you can. I just like to write the symbol. And so a postulate as well. So we've been dealing with a lot of theorems. This one's a postulate. So a postulate is a statement that is argued to be true but cannot be proven to be true. Alright, so if we have these two triangles and all the sides are the same from one triangle to another, then therefore they are congruent to one another. Okay, given the diagram shown, are the triangles congruent? So I noticed that we have 9, 7, 5, and we also have 9, 7, 5. So yeah, all the sides are congruent to one another. Well, not individual sides, but with the other triangle. So yes. And then, so that would be how we know. So the three sides are the same as the three sides, not tree, three in the other triangle. Alright, and so if they are congruent, write a congruent statement. So, congruent statement, we need both the triangles. The first triangle, it doesn't matter how we decide to write it. The second triangle, we have to make sure we match that up. So I started with A. I don't know the angle measure, but I do know it's between 9 and 7, right? 9 and 7. So F is between 9 and 7. Alright, so I'm going to start with F. And then I went to B, and then I went up to C. So I went down 7 and up 5. So I want to go down 7 and up 5. So DE would be my other triangle. Okay, reflexive property. The reflexive property states that any side or angle is equal to itself. So that may seem a little bit redundant, but it's very helpful when we're writing our proofs and being able to say, yes, this side is in fact equal to this side. Maybe you're talking about two different triangles that share a side, like here in example 2. So some things we might see is like AB is congruent to AB, or maybe angle A is congruent to angle A. Something like that, whether it's a side or an angle. Okay, so given the diagram show, are the angles congruent? So we see that two of their sides are the same, and then they share this side right down the middle. So if we don't see, because we have one large triangle, but then we have two smaller triangles. All right. So we have those two triangles there, and they overlap at AC. And so using that reflexive property, I know that AC is congruent to AC. So yes, they are congruent because, so how do you know? Sorry. AC is congruent to AC with the reflexive property. And now we want to write their congruent statement. So let's start with triangle ACD. So I start at A, down C, down to D, and then so it's going to be ACB for the other one. So I started with A to C to D, and so I'm still starting in that same place in my other triangle, and I go down the 3 side across to the B. So they both start out the exact same way. All right. Let's go ahead and check out this second exploration. So take a second, type out the link, click on the link online, and make a conjecture. All right, let's talk about these vocabulary words. So included angle. An included angle is the angle inside two sides of a triangle. The sides of the triangle are the sides of the angle. So we have two specific sides we're working with. So that would be their included angle there. All right, side angle side postulate. If two sides and an included angle of one triangle are congruent to two sides and an included angle of another triangle, then the triangles are congruent by side angle side, or SAS. So we're dealing with these two sides here where we have our 1 line and our 2 line, and then we have angle C. So it has to be that angle. It could not be this angle, and it could not be angle B either, because neither of those are included. So yes, they are on the inside of our triangle, but we need included angles. So if we even think about like how it's said, side angle side, they should go in that order. So side, then our angle, and then our other side. If we had something, I'm going to use this triangle, if we had this angle over here, and I tried doing that same thing, I would do side, angle, and then my next side would have to be this one, as you're reading it, right? Side, angle, side. But we don't have that side all the way over there, which is why this is our included angle, and these two triangles would be congruent. All right, example 4. Which postulate can be used to prove that triangle RST is congruent to triangle PQT? So looking at the information we have, which one do you think it is? So I'm going to give you a second to try it out. All right, so it will be side, side, side. That is because we have this side, those two are congruent, then we have the 1, and then we have the 3. And so we have those 3 sides, and we could say they are congruent by side, side, side. And if you also think about it, side angle side, we have to have an angle, and none of these lines are talking about an angle. All of them are about a side. So you really have to pay attention to what is it giving you, what are you looking at, and we're looking at all the sides, and it's not telling us anything about the angle. So if I take a look up here, right, it tells us about the angle. It would have that little curve mark, or maybe in some cases maybe it'll have a number. But in this case, we have nothing about an angle, so it could not have an angle. Or it could not be side angle side, sorry. Okay, example 5. I want you to take a second and think about this one. So which postulate can be used to prove that triangle LMN is congruent to triangle NQP? All right, and I got side angle side. So this time we do have angles, right? We have that 90-degree angle box in that corner, and it goes in order. So I have side, and then my angle, and then my other side, and they're all right next to each other. I shouldn't have to lift up my pencil at all. They should be all flow like that. So side, angle, side, and they match up on NQP as well. So side, angle, side. Okay, let's go ahead and head to the next page. So we're going to be talking about some proofs today. Proofs. So a 2-column proof is a method of collecting evidence to justify a conclusion. Evidence that can be used includes given information's definitions, theorem, postulates, and properties. And these are going to be some of the ones that we'll be using. You guys can reference that as needed as we fill this out. And real quick, guys, a proof is just showing all of your work on paper. So as you would go through it in your head and you're like, okay, well, this equals this because this equals that, so therefore this has to equal this. And you usually do that in your head, or maybe you write a couple things down. But a proof, it shows you, and let me scroll down, where we have these two columns where we come up with a statement and then we have our reason for that statement. So let's go ahead and try example 6. So example 6, we are given that HI is congruent to IK and JI is congruent to IJ, and we want to prove that triangle HIG is congruent to triangle JIK. So one of the first things I like to do is take my given information and mark it on my triangle. Sometimes, or my diagram. Sometimes it is already marked, but in this case, as you can see, it is not marked. So I'm just going to mark it. So HI is congruent to IK, and then GI and IJ. Alright, so I have those two there. My very first statement is going to be what is given to me. So HI is congruent to IK, and GI is congruent to IJ. And my reason is because it's given to me. So that is my first statement. It's because it is given to me. So that is my reason. That is my reason why I know that these things are congruent. It's because it is given. All right, now I have to come up with another statement. So we don't have enough information to use side, 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 or side angle, side. But if we take a look here, right across here, these are vertical angles, and vertical angles are congruent. So I can take these two angles, I can say angle HIG is congruent to angle KIJ, and the reason is vertical angles. So since they are vertical angles, they are congruent. So therefore I write out, yes, they are congruent. All right, and then my final statement, so now I have side angle side. Oh, perfect. So I can now say that triangle HIG is congruent to triangle JIK because of side angle side. All right, let's go ahead and take a look at 10. So once again, I'm going to go ahead and start with my given information. I'm going to mark it up. So KG and HJ, all right, and then HJ, or KJ, sorry, KJ is over here, and HG are congruent. Okay, so let's go ahead and put that in here. KG is congruent to HJ, and then KJ is congruent to HG, and that is because it is given to me. Alright, so before I can even start trying to figure out what my other statements and reasons are, I need to figure out what I'm trying to prove. So I'm trying to prove that these two triangles are congruent. So as I can see, I have two sides, but I don't have another I don't have an included angle. I also do not have a third side. So I need to prove one of those things in order to show that they are congruent triangles. So there's a couple different thought processes that we might have. You might say, oh, well, this is a perfect rectangle, so therefore these are 90-degree angles. We cannot just assume that. Yes, it does look like a very nice rectangle, but as far as we know, maybe it's slightly off and it's 91 degrees or it's 89 degrees. So we cannot assume that these angles are 90 degrees. But I do know that this side here, that is shared between the two triangles, and therefore it is the same line. So I can use JG is congruent to JG by the reflexive property. So because of that reflexive property, I can say yes, this side is equal to this side, and now I can say that these two triangles are congruent. I can see my side, 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 given. So they are congruent by side, side, side. That is my reason why we end up knowing that they're congruent. Alright, I want you to go ahead and try example 11. So go ahead and pause the video. Then when you unpause it, hopefully it should pop up. But I want you to go ahead and try 11. The midpoint might be the tricky part in this part. But take a look at the last page where it says evidence. And you can use some of those for your reasons. And remember what we know about the midpoint. So if you don't remember what a midpoint is, take a second and look it up. Alright, so here's 11. So I used that midpoint, so hopefully you were able to look up what the definition of a midpoint is. So a midpoint cuts a line in half. So if C was the midpoint of B and D, then BC and DC are congruent to one another because of that midpoint. Alright. Another thing to think about is maybe you were thinking, oh, I can use a reflexive property for AC. So 1, 2, 3, instead of using the midpoint. So I'm not saying including the midpoint. So instead of using that midpoint, you're like, oh, well, I want to say AC. Well, now we don't have side angle side. So I cannot have side and then an angle. Let me highlight that. So I have side and then angle. And then my next side would have to be right there. It cannot be this one. So that doesn't make sense to use that reflexive property there. You could use the reflexive property. It would add another step, and then you could say side, side, side. But we had that angle, and then we had that side, so it ended up working out. So we didn't have to use the reflexive property and use that extra step. All right. Let's take a look at example 12, and let's do this one together. So this one already gives us some reasons, so we kind of just have to fill out the statements. So our given, all we have to do is rewrite that first step. So xz is congruent to rz, and yz is congruent to qz. So I'm going to go ahead and fill those out. So xz here, rz, and then yz and qz. Alright, and our goal is to prove that angle y is congruent to angle q. So this time we're not just proving the triangle, we are proving the angles. But we do need to prove the triangle in order to prove the angles. Maybe not in all cases, but in this case we do, and especially if we look at our reasons, we have side angle side, so we do know that we're going to be proving a triangle somewhere. So our reason is vertical angles are congruent. So if I take a look at my diagram, I see I have vertical angles here, so I can go ahead and create angle statements to show that those are congruent. So x, z, y is congruent to angle r, z, q. Alright, so now I have my side angle side to prove the triangles. So triangle x, z, y is congruent to triangle r, z, q. Alright, well now I have the triangles proved. How am I going to prove y and q? So last class we had talked about CPCTC, which is corresponding parts of congruent triangles are congruent. So we now have congruent triangles, right? We have just proved that they are congruent, so therefore all of their corresponding parts also have to be congruent. So if I see y and q, they're in the same position, so therefore I can now prove that y is congruent to angle q by CPCTC. So corresponding parts of congruent triangles are congruent. So we have those congruent triangles, and the parts of those triangles are congruent. Alright, go ahead and give 13 a shot. So this one has 2 statements filled, and then your very first reason filled out for you, so the given. So I'm going to give you a second to try this one out, see how it goes. Alright, so hopefully you had a chance to fill that out. Here is example 13. So given, what's given to us, and I marked it on my diagram as well, so I knew what I was working with. I proved that this middle line is congruent to the middle line. So I was able to show that the two triangles are congruent by side, side, side. And since the two triangles are congruent, all of the corresponding parts, so all of the sides, all of the angles are congruent. So corresponding parts of congruent triangles are congruent. All right, and that is the end of 4.3. If you have any questions, feel free to ask your teacher, rewatch the video as much as needed. Have a great day.